Hi everyone, happy Juneteenth. I'm Ayodele Odubela, and I'm excited to be talking about bias in machine learning with you guys today. Hi everyone, I'm Ayodele Odubela, and I'm excited to be talking to you guys about bias in machine learning today. So let's set a basis about what bias really is. There's two kinds of definitions, and there's a technical definition in machine learning that has to do with error rates, but the way we'll be referencing bias for the rest of this talk is going to be how we see it in society, so the prejudice in favor of one group over another. The reason that this is an important distinction is that the bias that is in society is actually encoded in our data, and it's not the same as the bias when we're talking about building like neural networks. So digging a little bit deeper into this societal bias, there's two ways we can think about it, and that's explicit and implicit bias. Explicit bias is those things that are easier to spot. They're on the outside and things that are just our beliefs in general about specific groups. But implicit bias is more insidious in that it can really influence our behaviors, and it's a lot harder for us to understand. So a lot of the factors that impact implicit bias are your environment, the people around you, whether or not you are in a diverse area or not. A lot of those things impact implicit bias. And since those are harder to point out within ourselves, it's so much harder to point out within data. The reason that's a problem, though, is that every single bias that's held inside of our training data is going to be perpetuated by the models we create based off of it. So you're seeing some examples that you may have heard of in the news recently about bias impacting Black people specifically. And it's crazy because I did this talk a year ago and I was covering a whole different slew of algorithms that have impacted us negatively. And now we're still seeing these same algorithms not really getting an overhaul or an audit. So just by drawing more attention to this issue and hopefully inspiring more of you guys to work in machine learning, that we'll maybe try and see some change hopefully soon. So the biggest factor here is awareness. I think one of the big reasons that this bias is perpetuated by these models is the fact that so many data scientists and engineers are just unaware of the bias that's within our data. If you're not, if from a really heavy statistical background, it's not super obvious that we need to be stratifying our sampling data sets and our training data based off of the demographics and trying to match those to what we see in real life. That's a huge problem, especially because we know that facial recognition is one of the areas that severely impacts people. It's one of the areas that severely impacts Black people, especially the darker we are. But at the same time, so many of these training data sets focus on, they're not skewed intentionally, but if we're looking at like IMDb data, we know that the vast majority of actors in Hollywood are white and male. So that bias is going to be impacted by every single model that uses that data to train. So a couple of ways that we can start to fix this is really by documenting our data sets better. In industry, we are horrible about this. It's easy because it's perpetuated by boot camps and by grad school that you should just be able to pick up a data set and start playing with it. But the problem is we're never really critiquing who created that data, the sampling methods for that data, so many factors that actually influence the data we have, we're not trained to inspect. And on top of that, those are the areas that are harder to find later on. So if we do end up using specific data for modeling, and then we find out later that there were biased survey results, they did not send surveys to people in specific zip codes. So many times in industry, we're not going back to correct these models. So I think by starting off with better data set documentation, it'll just be so much easier going forward. And especially if we use projects based off of these public data sets, we're not there's no standard for how they're compiled. There is no ethical standard or requirements they must meet. So as practitioners and as people who care about how bias affects Black people, we need to be pushing big companies to be more transparent about how they get their data and how it was collected. Another area that is obviously controversial is sexuality and gender detection. I think it should be obvious that this is not something we want to use machine learning to predict. Not only is this going to be wildly inaccurate and in most cases kind of a useless use case, we have to understand that it's in some aspects just unethical. So I have even in the past been asked to try and predict people's gender based off of their names. And as someone who has a unisex name, it was important to me to highlight a lot of the issues there. And I understand how if you're trying to market your app or if you're trying to build a business strategy, these might be important insights to know, but we need to know when to say no to using machine learning models for this. And another hot topic that's been in the news, it has been facial recognition. So it has failed at identifying people of color. It's not just that the facial recognition is bad, it's that it's being used and being sold to police departments who have this racist history of surveilling us and policing us unfairly. Another way that facial recognition has boomed recently is in flight boarding. So I find this very frustrating. Not necessarily that it's a product I've used, but we probably should not be doing this use case with machine learning. There are so many reasons why, and I think only one sliver of it is that it's inaccurate for Black people, but there's always going to be a trade-off. If there is a technology that makes something easier for some people in a zero-sum area like flight boarding, if some people go through security in 10 minutes, some people are going to take longer to go through security based off of the TSA data we already have. So if we are more likely to be misidentified or trying to board our flight, we're going to be more likely to miss that flight. And on top of that, a lot of times if you need to reschedule that, there's additional fees on top of that. With the way the systemic racism works, it just keeps perpetuating this problem. So it might take very fair-skinned people an easy time to get through, and this might be a product that they love, but we have to consider the trade-off on the other hand. And another aspect of facial recognition when we're talking about not only race but gender as well is that almost every single facial recognition algorithm ignores people who are non-binary. And the hard part here is that so many of these companies are building systems to operate within what our general classifications for gender are in the United States as they're collected by the EEOC and respected by big companies. But that leaves a lot of room for error. If we understand how many people are trans or non-binary, they're not even being included in the vast majority of these algorithms, which makes us really start to question how well are these algorithms performing if they're trying to test against the ground truth. What is that? It's very awkward for a company to try and ask you, what gender are you really, when they're just looking at an image and trying to determine what gender you are. So we'll talk a little bit about the impact of bias data. These are a couple areas that are really specifically impacted by the training data that's available. And let's talk about a couple of the effects. So a couple of these algorithms it boggles my mind that we are still using these. There have been a couple There have been a couple developments though. So I know Los Angeles County is not going to be using PredPol anymore, which is their predictive policing algorithm that's used not just in LA County, but in a lot of counties around the country. So the main problem here is that these algorithms are basing their new predictions of where they think crime is going to happen based off of this historical data on where crime has happened before. The main problem with that is really just the training data. So if we understand that policing in this country has been biased, all of the policing data in this country is biased. If we're using that to train new models, we're going to see not only the same areas being predicted as more dangerous, which are more likely to be inner city areas, but we're also going to see increased policing in these areas. And the major problem with that isn't just that, great, they caught more bad guys. It's that it is a lot easier to spot crime when you're looking for it. And we know for a lot of these urban communities that, or really, let's be honest, we know for a lot of these Black neighborhoods, they're already policed more. So sending more police out to these same spots is not going to fix the algorithm, essentially. But what it does is create this feedback loop of where that algorithm is then not given new data on whether the person who they arrested was actually committing a crime to begin with. Not only that, these algorithms don't take into account people who may have been found innocent of these crimes. It's not getting that kind of feedback, and that's one of the hardest reasons that it's a hard to fix problem. And then we go into race-based HR, which I think is one of the worst areas to use this bias training data, because the same people are going to end up being hired. So if companies, especially big companies in tech who have less than 5% of their employees as Black employees, very few of those people are in management. Very few of those people are in technical roles. So if they're using their data about their top performing employees, knowing that at these companies, it's more likely than not that they were working in a toxic environment that openly perpetuated racism based off of multiple stories of people who have been in these roles. If we are only using the ideals to try and hire new people, we're going to just create these echo chambers at work and hire only people who are similar to the people we've been hiring. It honestly is just algorithms perpetuating the same things that we would do in the same biased ways we would do it. A couple other ways that have severely impacted Black people, honestly, that the travel ban, the algorithms easily reflect xenophobic bias and use limited examples and then misidentify people. So that xenophobic bias is not just from having dark skin and facial recognition, but specific names are easily flagged, and names from countries that sound foreign, for example. And even when we change realms and we think about like the online world, there are so many companies who spend millions and millions of dollars into putting out these online ads for horrible predatory credit companies. And they specifically target users by race. Twitter is able to target users by race, and so is Facebook. They're also able to exclude specific races, and advertisers have done this in the past to not have certain people buy their products. These are just some of the small ways in which these algorithms have massive impact on our lives. So I think that by drawing some attention to this and then by showing some solutions, we can try and positively impact the way we use machine learning in the future and really focus on using AI for good. So I think this is really powerful when we're talking about people who want to be in data science or machine learning. One of the biggest things that I've learned in my career is that we as technologists have a lot more power than we probably should in building these products. Very oftentimes companies are new and want to move fast. AI is hot and it's sexy and it's talked about a lot. But at the same time, we really need to understand how we're able to impact real human lives with what we're doing. So this is kind of reiterated a lot, but whatever bias data you have, it's going to impact your outcome. There's no way to take biased data and make a model that isn't biased off of it. Another aspect here is that humans are imperfect. So we have to assume that bias exists in our data and it's going to exist in our model until we take steps to remove or mitigate it. So when I'm looking at driver risk data on the day-to-day, I understand that regardless of what state I'm looking at, Black people are policed, arrested, and stopped in these basic traffic stops at a higher rate than people of every other race. Knowing that, I can change the way that I model this data or I sample data to make better algorithms. And I think what's really hard here is, especially as data scientists, we are masters of our own demise. It is the only job I've ever had where I get to set my success metric. I get to say if I'm going to use accuracy or if I'm going to use precision or recall or other metrics like R squared or F1 score. All of these are different ways to measure how well a model performs. And what you may not know is that the people working at Google and Microsoft and these big companies making AI, all of them get to set their own success metric. So it's very easy to choose the metric that looks the best. It's very easy to try and manipulate the data until we tease something out of it. And so that's part of the problem, is almost this demand for results and the way that we do for software engineering. But data science as a true science takes more consideration and care than wanting to just rush in and create products for the sake of using machine learning. So the impact here, one of the reasons that we have so many issues with this training data is because of how it was collected. So if we think about how cameras were developed and a lot of other hardware is developed, like radio frequency sensors, like the TSA uses in the body scanners, none of these technologies were really made for Black people. And that is kind of the hard truth. Regardless of how I've worn my hair, whether it's natural, a weave, a wig, no matter what it is, it takes me longer to get through TSA checkout, and I have to have my hair patted down like I'm carrying a knife, because these sensors do not recognize our hair because their training data has been mostly white people. And cameras specifically have been tuned for lighter skin tones. That's one of the reasons that we have trouble taking night photos at night. That's one of the reasons that facial recognition performs so poorly on us, is that there is typically not enough light reflecting at us for the camera to actually pick up all of the small differences in our skin. So I don't know if you guys have seen this, but this is one of the old time camera calibration cards. Cameras were literally tuned to look better for people with fair skin. So if you don't look like this, there is no chance that even our modern day grandchildren of these cameras trained in this way, there's no chance that you're going to be recognized in the same way. So what I'm really calling for here, though, is for action. If we're in an age where people aren't really scared to call out companies anymore, and this is such a pervasive problem that we need to call it out and we need to take these steps. People need to stop considering these edge cases as something that, it can happen in 5 to 10% of the cases, but just throw away why these are happening. I think that's been the trend so far in industry, is we'll deal with it when we get to it, and we just can't continue to do that anymore. It's just not the right way to do things. We have to we have to recalibrate these edge cases, or cases where Black people might not be recognized, or women might not be recognized. Those edge cases need to be seen as the baseline, not implemented in V2, not a fix, not a patch. But if we start modeling for this as a baseline, it's a lot easier to cover everyone else that the camera is tuned for. If we can detect this dark skin, we can detect light skin, but it does not go the other way around. So part of that solution is really pushing to not use machine learning in some cases. Policing data should probably never be used for modeling. It's interesting to explore. It can give us insights about policing in different regions, but no matter what, our policing data in this country and pretty much around the world is racist and always will be. There's nothing we can do that's going to create a new model based off of this kind of training data that's not going to perpetuate the same racism that policing perpetuates. And then we should be testing our models, making these unit tests for these edge cases. So testing hardware on dark skin first. There's no reason we should walk into a bathroom and not be able to use a automatic soap dispenser. If you test for dark skin first, it is much easier to also have that product work for people who are lighter. And then I think just having an extreme skeptical attitude towards machine learning is going to bode us better as a society just in general. We tend to blindly accept machine learning for, it's supposed to be this cool thing that's a utopia, and all of the shroud of mystery around it makes it easy to just believe what the model is outputting or what your results are and not really question that. But we need to think about it like a science. We need to be asking these hard questions of companies who make these products. So there's a couple technical ways we can evaluate these models that I'll cover. The first is FAIR-ML. So there are a couple different evaluation packages such as FAIR-ML that will help you as a practitioner understand which aspects or which features are impacting your model the most. So that's also in line with TCAV. So that's just another method for understanding a neural network specifically. So neural networks are seen as black box models, and thankfully that's not, doesn't have racist background. That's just because they are opaque. We can't see into them. We don't really understand what's happening inside. So what TCAV does is it allows people who build these neural networks to understand which features are most important in impacting how this model made a decision. And then shapely values, this is a statistical method really to just understand again which features are most important. If we're making models and we have higher shapely values for proxies for race or gender, such as zip code, we consider not only removing those features from the model, but shapely values will give us just more concrete evidence of how our models are performing and based off and which features are causing it to perform well. As far as adversarial ML, this is really important when we're thinking about computer vision, natural language processing, audio processing. It's really building these bad machine learning models or building training data for models in a way that is supposed to break the model. So one example is there are ways you can distort images and move the pixels around so that an image of what just looks like white noise can be registered by a computer vision algorithm as a panda or a giraffe or any other type of animal or icon you can encode. So we have to understand with these facial recognition technologies, there are also plenty of people who are wanting to fool this tech by not being clear about who they are. There's a lot of facial jewelry you can wear. We need to understand and build models in a way that we are mitigating and we are expecting these kinds of things to happen. And a lot of people in industry don't work enough on breaking their own models to try and make their models better. So next, if we're going to talk about training data, we really need to talk about proxy bias as well. I already covered zip code a little bit, but another area that is really pertinent for proxies is word embeddings. So it's hard for us to quantify words. We have to try and make these mathematical correlations between things like king and queen, which, even just as an example, exclude trans and non-binary people. But there's also sexist cultural norms that can be embedded here. So if king is to queen, we are running the risk of it being super easy, which it is, for models to encode roles like teacher and secretary to women, and encode roles like doctor and lawyer to men. So a couple actions we can take here, and the first is a mindset change. For anyone who is coming in contact with machine learning, or if you see a product that says personalization on it, you have to understand there was some aspect of bias in how they created that model. So whether it's that training data or whether it's the actual people who created these models, we have to take a mindset change and just be more critical. Alongside that goes accountability. We have to be able to build some of this user trust by using open algorithms. So being transparent about the algorithms, especially when they have a really large impact on people, is really important. So if you are interested in bias in machine learning, I really recommend these books. These 4 have kind of set my foundational knowledge, have informed me of a lot of the examples in which bias in machine learning can be really, really detrimental, especially to Black and brown folks. And that's all I have. Thank you guys for listening.